In this question, we'll briefly go over the Bohr model and how to find the energy of an electron in the Bohr model. Now, one of the limitations of the Bohr model is that it can only have one electron. So the Bohr model has the nucleus in the center. And it has a single electron orbiting that nucleus. Now, these electron orbits go in levels. The level closest to the nucleus is referred to as n=1, with higher levels being further away from the nucleus. Now, we are asked, what is the energy of an electron in helium plus if n=2? So we are being asked about the second level, not the first level. First level would be considered ground state. While any levels above 1 are called excited state. Therefore, n=2 would be the first excited state. Now, to find the energy in this electron, we use the equation E is equal to K times Z squared over N squared. E stands for energy, and this energy will always be in joules. K is a constant that relates energy to the other pieces of information. It is automatically 2.18 times 10 to the negative 18th joules. Now, Z is the number of protons. The higher the number of protons, the more energy of interaction between the electron orbiting the nucleus and the nucleus itself. Now, for helium, we can look at the periodic table. Helium's located in the upper right corner of the periodic table, and it has an atomic number of 2. Therefore, we'll say that Z=2. The lowercase n stands for the energy level. This is given to us in the problem in line 1. We are told directly that n=2. Therefore, we know K, we know Z, and we know N. And now all that's left to do is do the calculations to solve for energy. We'll say that E is equal to the K value, which is 2.18 times 10 to the negative 18th joules, multiply by 2 squared from the Z. On the bottom, we place the N, which was also 2. We can see that if we have 2 squared over itself, these simply cancel out. This gives us an energy of 2.18 times 10 to the negative 18 joules. This will be our final answer. We can also find the radius at which that electron orbits the nucleus. Here we have the same helium plus and the same level. Now, anytime an electron orbits the nucleus, we'll have a certain radius or distance between the nucleus and the electron. We'll label this R. Now, this distance depends on both the level and the number of protons. The equation we use to find the distance between the nucleus and the electron is R equals N squared over Z times A. A is called the Bohr radius. It is a constant, and it's equal to 5.292 times 10 to the negative 11 meters, which means when we do the math, our radius will be in meters. Now, recall that the distances between a nucleus and an electron tend to be very, very short distances. So we'll have scientific notation with a large negative number, most likely for all of these problems if we are doing them in meters. N is still the energy level. We are given in line 1 that N is 2. Z is still the number of protons. Since we are still using helium, we still have 2 protons. Now we place our numbers in the correct positions. We know N, we know Z, and we know A. We'll say R is 2 squared for N, divided by Z, which is also 2, multiplied by A, which is 5.292, times 10 to the negative 11th power. For our answer, we'll have 1.058 times 10 to the negative 10, and our answer will be in meters. Some questions might ask you to find the number of angstroms rather than meters. Angstroms will be represented with an A with a circle over it. To get that, all we need to do is multiply our answer in meters times 1 times 10 to the 10th power. If we do this operation, the E10 and the E negative 10 will cancel out, leaving us with 1.058 angstroms. And so this is how we find the distance between the nucleus and the electron. Now mind you, this only works if we have a single electron. If we add any more electrons, this changes the math completely.